So now what we're going to do is write a bit of code, and we're going to write code that implements the many-to-many relationship. And so if you recall from before, a many-to-many relationship is a situation where you have many courses on one side and many users on the other side, and there's many users that are members of many courses, and a particular user can also be members of lots of courses. So there's many on both sides. And we don't have a way in a database to really represent this directly, so we make this thing that Wikipedia calls a junction table. I don't know, I call it a many-to-many table. And what we do is we decompose the many-to-many relationship into a pair of many-to-one relationships. So we create this table that is the join table, the table to connect them together, and it effectively has two foreign keys that point outwards. And then you can also model certain things. So sometimes you, in this case, we would model the role of the student or your teacher or whatever. So you're a member of the course, but there's something about your membership. And there's sometimes a few other things that are sort of down here on this connection. But you have two foreign keys, and what's also interesting is there's no primary key, right? No primary key, and that's because we create a composite key that is the combination of these two things. So we basically say user ID and course ID together. So 1, 1, 1, 2, 1, 3, any combination of those numbers is itself a primary key. We call that a composite key. Okay? So what we're going to do is we're going to talk about how we will insert data into a user table, insert data into a course table, and then insert data into this connector table. Okay? So let's take a look at the code. And what we're going to do is we're going to actually, in this case, instead of reading XML or reading from the web, we're actually going to read some JSON data that I provide. And what this is this is JSON that's a list of a list. So each list here is a name, a course, and a role. And so this is the instructor of SI 110, this is a student in SI 110, and if you scroll down, you see then sooner or later, after a while, we have SI 106, and then we have the instructor of SI 106. So we're going to write a bit of code that reads this JSON data, parses the JSON data, and then loops through what effectively are JSON records, one at a time, inserting into the user table, inserting into the course table, and then using the foreign key to connect these things together, okay? So Charlie is on one side, SI 110 is on the other side, and then we have to make the connection. So what we really have to do is establish a primary key in the user table for Charlie, establish a primary key for SI 110 in the course table, and then we just insert a single row, which is pretty simple and pretty easy. Okay, so let's take a look at the code. Here's the code, roster.py. Now, some of these things are going to look pretty comfortable by now. We import the JSON library, import SQLite 3 library. We make a connection to the database, rosterdb.sqlite, and we get a cursor so we can send commands. So this next bit is a little bit different than we usually do. Usually we say cur.execute, but this time we're going to say execute script, and that's the difference. We're saying execute script. And this is a triple quoted string, so that's one long string with new lines and all that stuff. And what we're able to do in execute script is have multiple SQL commands, and so we can say drop table if exists, drop table if exists. What we're doing here is we don't want to have to delete this file every time we restart, so we want to start with fresh tables so we can drop them and recreate them. And drop if exists means the first time when you first create it that won't exist, so this does absolutely nothing. But by the time we get here, those three tables will be gone. We're going to create a user table, and the only thing we're doing different than we usually do is we've added this unique. So what this basically says is within the table user, the name column must be unique. So there can't be two rows that have the word Chuck in them for the name. And this is a rule that we're making for ourselves, and if we violate the rule, SQLite will yell at us or fail or whatever. Now, in a bit, we're going to use this to our advantage. And so the same thing is true for the course. And we got a primary key, and then we got a logical key that we're basically saying the title of the course must be unique. And then we have our little connector table, our junction table connector table, and it has two foreign keys. They look just like every foreign key we've ever made, except what we're saying here is primary key, user ID, course ID. So we're saying we have a composite primary key here that is the combination. So 1, 1 or 1, 2 or 2, 1. It's like these are concatenated together to make the unique key. So neither of these two is the primary key, but the primary key for the row is user ID, course ID combination. And this is also a uniqueness constraint so that we can't doubly insert this stuff as well, okay? So that, when we're all done with that, we got three tables set up the way we want them to be, okay? Okay, so We ask for a file name. If we hit enter, it's going to be rosterdata.json. Probably you'll just hit enter on this all the time. This is kind of the syntax of that file. We're going to open the file. We're going to read the whole thing, get that into string. We're going to load it. I mean, we could put try excepts around here, but hey, the data is going to work, so it's just going to work. So now JSON data is a Python list. So we're saying for entry in JSON data. So what that's going to do basically is entry is going to iterate through each of these things. So entry then is a 3-element array, 0, 1, and 2. And so it's like, oh, the name is entry sub 0 and the title is entry sub 1. So we're pulling the name and the title out of this data. We've read it. This is one of the things that everyone loves about JSON so much, is that the reading it, the parsing it, the looping through it, the hunting things down is very instinctive, because it's nothing but lists and dictionaries depending on whether the bit of JSON starts with a square bracket or a curly bracket. But other than that, it's all good. Then we print the little guy out. Now, this is where we're going to take advantage of the unique constraint. So we're going to say insert or ignore. So what or ignore really in general is saying is, if this insert would cause an error, do nothing. So it says insert this or ignore it. And the particular thing that's going to go wrong here is a violation of the unique constraint that we put on the name column, So insert into username. Remember, ID is a primary key, so we don't have to say that. And then we have values, question mark, and then we have the little tuple with one little extra comma guy. Sorry about that syntax, but it's what we got to do. So what this does is, if this is the first time we've seen name, it inserts it and gives that a primary key. If it's the second or later, it doesn't insert it. We're kind of like behaving like a dictionary, like we did in some of the other database programs. So this either inserts or does nothing, but what we're sure of at this point, from this point forward, we know that there's a record and a primary key. So now what we're going to do is we're going to look up that primary key and say, what was the primary key, either given immediately, one sentence earlier, one statement earlier, or a long time ago. Whatever it is, select the primary key from user where name equals name. And so we insert it or ignore it, then we do a select. So between this almost becomes an idiom by the time it's all said and done. Is this little bit's an insert or ignore, and then select. And this says, put it in or not, and give me the primary key when you're done. Then we just say user ID equals cur.fetch1. Say, give me one row from this thing. There should only be one row. And then the sub-0 element, because we only are selecting one column from the database. Okay. Then we do the exact same thing again. It's an idiom at this point. You just grab this three lines, and then we paste them down here. Insert or ignore into the course with a title. That's got a unique constraint on it. And then we're going to do a select where, and then we're going to have a nice little integer number, which is the primary key of the course, whether we just inserted it or not, okay? So that's in good shape. So at this point, we have inserted a record here, we've inserted a record there, and we have the value for this and this sitting in two variables. Like I've always said, some of these things where you got to put foreign keys in are easier in Python, because you don't have to write down like in a little cheat sheet, right? Here's like a little cheat sheet here. Like, what are those numbers? Well, we don't need to know what those numbers are, because we have them conveniently in variables. Course ID, user ID. So give it to me, whatever that number is. Don't have to write it down. So we're just going to insert or replace. This is because the combination of user ID and course ID is a primary key. So if somehow we see the person in the course twice, it'll just update it. So it's like this is a combination of an insert / update, DATE. So insert or replace, it's just don't blow up if it's already there. Into member, user ID, course ID, two values, and then user ID, course ID. And then we're done. We really have established that little connector with the two foreign keys, and then we commit to make sure that we write it to disk. And then we run this one time for each of the things. Okay? So pretty easy, pretty straightforward. Let's run the code. Okay, so I'm in the code / roster. And so if I take an ls, I have roster.json here and roster.py. And to run the code, I just say python roster.py. And at this point, a database has been created because the execute script was before that. So let's take a look at the database structure. There is no data in it. So let's do an open database, rosterdb.sqlite. So we've got these things. They're all created exactly the way we wanted. Now you would normally not bother stopping and looking, but if we take a look at the data, there is no data in here, okay? There is no data. And so I'm just going to hit enter, which means it's going to assume the roster data.json, reads all those things, inserts all those things, commits all those things, and now we can go back and take a look at the data. And there it is. The data is already there. Here's all the users in the user table. Simple enough. Courses in the course table. Simple enough. Primary keys. And then the member table, which is nothing more than a bunch of rows with 2 primary keys in them, pointing to the course and to the user on either side. And so there we go. Pretty much that's all we really have to do let's go up here, to implement this picture of a many-to-many relationship that we've decomposed into 2 many-to-one relationships.